Hello everybody, welcome back to another video. Today we're going to be talking about how we can use the K nearest neighbor algorithm to predict iPhone sales. Let's not waste any time, roll the intro. So now the question is, how does the K nearest neighbors algorithm work? So let's say we have a two-dimensional feature space where we have some red points, some green points, and some blue points. And we introduce a new data point in between all of those points. We're trying to identify with this algorithm what class this data point fits into, red, green, or blue. So the way the algorithm works is it takes the distances from the point that we introduced to all the other points. And we have a certain K value. And that K value is how many data points we're taking into account, how many data points we're measuring distances from. And then we take a majority vote. And this majority vote basically counts of the data points that are within a certain distance from the data point we introduced. Are they green, are they blue, or are they red? And if the majority is green, then our new data point that we introduced is green. If the majority is blue, blue, red, and so on. So the whole idea of the algorithm is we're trying to classify what class does a certain data point fit into based on its neighbors, its nearest neighbors. That's why the algorithm is called K nearest neighbors. Alright, so now that we understand how the algorithm works, let's implement it in code. So the data we're using today is data that gives us the age and salary of a consumer who might be buying an iPhone. And our job is to understand whether that consumer will buy the iPhone or not and predict it using our K nearest neighbors classifier. Alright, how do we do this? So first, we need to import our data, all right? So we need a couple of libraries to accomplish what we're about to accomplish. So pandas. We also need NumPy. We need Seaborn. All right? Pandas and NumPy are for data manipulation, and Seaborn is for data visualization, all right? Now, to import our data, we create a dataset variable and assign it to pd.readCSV. All right. Now, the way we read a CSV file and turn it into a Panda data frame is we take the file path and put it in this little method. So we have the file path here. If you guys want access to the dataset to implement this code on your own, that will be down in the description below. So now we've imported our data, so let's run this really quick. Alright, so we've imported our data. Let's look at what our data looks like. Alright, so the way we do this is we say dataset.info. Alright. Now really our data has 4 columns: gender, age, salary, and whether the consumer purchased the iPhone or not. For the sake of simplicity, we're going to ignore the gender column and remove it from our dataset to make sure that our entire process is simple and we don't run into any errors. So the way we remove a column from a dataset, really quickly, dataset.drop, and then we need the name of the column, gender, axis, where it's located, in place equals true, whether we're actually going to eliminate this from our dataset. As soon as we run this, then our data eliminates the gender column. So if we also again visualize our data with the info method, we will see no gender column. All right. So now we can start playing with our data. All right. So the first thing we want to do is we want to split our data into X and Y. All right. X is our features, so age and salary in our case, and Y is our target variable, what we're predicting. All right. The way we do this for X, we're going to use what we just used to eliminate the gender column to assign some numpy array to x. All right, we want to say dataset dot drop purchase iPhone. Why would we drop purchase iPhone and assign it to x? Well, we want to use age and salary as our columns. So the way we assign that to x is we say we want to ignore purchase iPhone, we just want age and salary. All right, but we don't need to address the in place argument this time. All right, and the way we get those values is we say dot values. All right, and the same for y, but instead of doing a drop, we just call on the column purchase iPhone. All right, so dataset purchase iPhone. All right, now we have our x and y values. Now we're going to use them to visualize our data, see what it looks like, and get some insights on what the data that we have actually means. All right, so we have our x and y here, as you can see. Let's get to data visualization. So now we want to see basically a graph where age is on the x-axis, salary is on the y-axis. We have all of our points plotted, and the points have two different colors. One, purple for people who did not purchase the iPhone, and yellow for people who did purchase the iPhone. How do we visualize this? We can do this in one line of code. Here we go. We say pandas.pd.plotting, and it has a subset called scatter matrix. All right, and scatter matrix has a few arguments that we can use to visualize the graph that we just talked about. All right, the first is we need the data set. All right, the second is we need our y, so our target variable. So c equals y. We need our figure size. All right, and we're just going to make that 8 by 8. And finally, we need another formatting variable that we're just going to add here. All right, now we can plot. This is a 3 by 3 plot, which has, distribution plots and different columns plotted, but really we're focusing on the middle left plot, age and salary. So salary versus age with the purple and yellow indications for whether the consumer bought the phone or did not buy the phone. All right. So here we go. We have this graph. We want to look at other aspects of the data to kind of understand, based on salary, what type of consumer would buy the iPhone? Someone with a higher salary or a lower salary? So the way we visualize stuff like this is we use distribution plots. And the way that can be accomplished is using the Seaborn library we initially imported here at the top. All right. So Seaborn SNS has a method called displot. All right. Displot has two arguments that we're going to be using at first. Our data and our x. All right. Because a distribution plot is basically the amount of every x value. All right. And you're going to see how that's arranged in the plot. So the x value we're going to be visualizing right now is salary. All right. So this is our distribution plot for salary. So we're going to see we have some amount of bins, a default amount of bins. We're going to see the distribution of salary across our data. Let's say we wanted to look further into the distribution of salary and say, hey, who is buying iPhones within this distribution? How would we do this? So we would add another argument called hue. And hue is essentially telling us whether the person bought the iPhone or not. It's a binary, so it's going to be either blue or orange. Orange for someone who bought and blue for someone who did not. All right? So purchase iPhone. All right? Now that we've added hue, we can see blue who did not purchase the iPhone and orange who did purchase the iPhone. All right? That gives us kind of an insight. We see people with higher salaries tend to purchase more. Now we see some people with $20,000, $30,000, $40,000 salaries that are purchasing iPhone. But majority of the data is skewed to the right, all right? So we see more people are purchasing iPhones when they have a higher salary, which is logical. All right. That's some cool data analysis we could do. We could also do this based on age. So if we replace salary and said age, the plot would look a little bit different. All right. The age doesn't really affect whether someone would buy the iPhone or not as much as we saw salary did. All right. So you can really use either one. And if you have data sets with more columns, you could supposedly make n columns of every variable you had. All right. So that's some exploratory data analysis for you. But now let's get into creating the k nearest neighbors classifier. We need a couple of libraries from sklearn to accomplish this. All right. The first one is our actual algorithm. All right. So from sklearn.neighbors, we want to import k neighbors classifier. All right. The second model or method we need to import is train test split. This is going to be able to help us split our data into training data and testing data, and I'll talk about that in just a minute. All right, so from sklearn dot model selection, we want to import train test split. Okay. Now our last import is going to be for evaluating the accuracy of our model. So from sklearn, we need to import metrics, and metrics is like accuracy. That's the only metric we're going to be using. All right, so let's run this. Okay, so we have all of our imports done. Now it's time to split our data into training data and testing data. All right, why is this important? We want to split our data so we can evaluate the performance of the model on what it learned on the training data, on what it when it understood the patterns within the data, and then on testing data it's never seen before. Okay, so how do we do this? We need to create 4 variables: xtrain, xtest, ytrain, ytest. All right, and assign that to the method train test split. Now we're going to be using our x and y variables when we define them back here. All right, so our inputs x, y, and then we need a couple more arguments here. Test size is the split between the training and the test and the testing data. What does that mean? 0.3 means that 30% of the data is going to be testing data and 70% of the data is going to be training data. That's just an accepted split in machine learning. All right, now we need some random states so we can replicate the production of this training and testing data. So we can assign this to any random number. 18 comes to the top of my head. All right, and then we need an argument called stratify, which is a way to organize the labels of our training and testing data, and we need to assign that to our target variable, which is y. Okay, so once we run this, we have split our data into training and testing data. Okay, now recall the explanation that we talked about before. We have some k value where we measure the closest distance points and take a majority vote, and of the points that belong to one class and the other, based on what wins the majority vote, we label that certain point. So if there's more points that say purchased iPhone, then that point is labeled purchased iPhone, and that's our prediction. But we need to have a way to basically understand and determine what our k value will be, because for different data, the k value might need to be different. So how do we do this? We need to make a for loop that runs through every implementation of our algorithm with a different k and measure the accuracy. How do we do this? So first we create an accuracy list that's going to store the accuracies, and we're going to use this to plot our accuracies so we can understand what k is the most advantageous. Here comes the actual usage of the algorithm, and this is really cool. All right, so for I in range 1 to 10, so our values are going to be ranging from 1 to 10. We need to instantiate our KNN algorithm. So we say KNN equals k neighbors classifier. All right, and k neighbors classifier has some argument, one argument in our case, and neighbors And we're going to attribute that to I because we're running every iteration a different number. And then dot fit. We're fitting our data according to our training data. All right. So X train and Y train. Okay. Now we want to store our predictions in some variable so we can test the accuracy of the model, right? So how do we do this? Basically what we do is we say metrics dot accuracy. All right, that's how we measure accuracy. Accuracy score. Y test. And our second argument is our Y predictions. How do we instantiate our Y predictions? So the way we do this is very simple. We say KNN.predict. KNN has, KNeighbors classifier has a .predict method. And we add to the .predict method our X test data point. All right. So we have our KNN classifier, we fit it, then we make a Y prediction, and then we measure the accuracy between the Y test and the Y predicted, and we append that to our accuracy list. So we say accuracy dot append that. All right. So we append that accuracy, right? And then what we do is we plot that data. All right. So we'll say plt.plot. Now for the x-axis, we need a range from 1 to 10 of the different k values. We're going to use our list accuracy, and then we need some color, some marker. We can make it fancy. We don't have to make it fancy, but for the sake of this video, we want to make it look cool. All right. So for the color of our points, we're going to make them blue. You can play with this if you want to make it look different. We'll say our line style, and there are a bunch of different ways to play with this. Our line style will be dashed. Marker can be any marker. We'll use X, all right? And you can, add marker size, all of that stuff, but it doesn't really matter, all right? And then we want to plot our X label as our K value. So now once we run this, we get this plot, all right? So we see out of all the K values we get, the highest value is 8. Now we can't use 1 because obviously 1 isn't going to give us any insight on the data, all right? So if you can't have a majority vote with one data point. Like you can't have a majority vote with one data point. You need at least 2 or 3, right? So, and we see the accuracy is the highest with 8. So now what we need to do is we need to train our model with 8 neighbors. So we need to re-implement what we just did. So we'll say KNN equals K neighbors. We can just copy this, but we're going to make the number of neighbors 8, all right? The same thing. Create those Y predictions. All right. This time we don't have to make an accuracy list. All we just need is this little line of code, metrics accuracy, Y test, Y pred. This is literally just copying from what we just wrote. All right. And then we can run this and we get our accuracy is 82, almost 82%, which is what our graph says. And that's the optimized accuracy level for our K value, which is perfect. All right. Now we want to visualize what our algorithm actually did. All right. And for this, we need a very specific library that not a lot of people know about, but it's really cool to visualize different algorithms that have decision regions. So clustering algorithm will have a decision region that divides between people who purchased the iPhone and did not purchase the iPhone. It's like a line, all right? It just indicates the split between the data, all right? So here's how we implement that visualization, all right? So the library is called mlxtend.plotting, all right? And the specific usage we're going to use it for is the decision regions method. So we're going to import decision regions. I believe it's plot decision regions. Plot decision regions. All right. Now we need to redefine x and y as the same thing we defined them previously, but we just need to change the data type to a numpy array because that's what this the library accepts, right? So all we need to do is run this. And now we need to use the plot decision regions method. All right. So we'll say plot decision regions. And plot decision regions has 4 arguments we need to use. All right. So we have our x, we have our y, and now we just need our algorithm. So KNN in this case. So the argument is CLF, and we equate it to KNN. And then we just need a legend to say 0 and 1 for the purchase iPhone column. All right, so legend equals 2. That's just the placement of the legend. And if we run this, we will get a visualization of how well our algorithm clusters between purchased iPhone and not purchased iPhone. Here the visualization comes, and this is what it looks like. So we see this decision boundary in the middle, denoting between the purchased iPhone and not purchased iPhone. You see the accuracy is not perfect. We previously said that accuracy is 82%, but this is still really cool to visualize this k nearest neighbors classifier with this graph. I hope you guys appreciated this tutorial. If you guys have any questions on how the algorithm works, how the visualization works, or anything you want to ask me down below, please let me know. I'm here to help you. Thank you guys so much for supporting my videos. I'd really appreciate it if you subscribe and like down below. It helps the growth of this channel. And I will see you in the next one. Peace out.